Section 18, we're going to look at some angles and circles. Quite a good start to these types of questions is to have a good knowledge of different properties of circles, which we'll start off by looking at. If I draw a diameter across this circle, if I then draw a triangle inside the semicircle, with the longest side being the diameter of the circle, that triangle is always a right angled triangle. So I can do the same down here, and it'll always be a right angled triangle. So it's important that you know that that property is that that triangle is always right angled. Another thing that's important to note is that if you've got a radius will meet a tangent at a right angle. Another thing to spot is isosceles triangles within circles. So if I was to draw a triangle here, that would be an isosceles triangle because this line here is a radius and this line here is also a radius, which means that's an isosceles triangle, meaning that angle is the same as that angle. Another thing to look out for in these questions is alternate angles being equal, that's Z angles, and corresponding angles being equal, and that's F angles. Okay, in this question we're going to look for the shaded angle. Now, quite a good way of approaching these questions is to not necessarily think about finding the final answer immediately, but just filling in what you can. We can see there that there is a radius and a tangent, so that angle there must be 90 degrees, which means that angle in there must be 90 degrees minus 58 degrees. So we're getting rid of the 58 degrees to leave us with 32 degrees. If that's 32 degrees, then that must be 32 degrees, and the reason why I know that is because that is an isosceles triangle. Since that's a radius and that's a radius, both these angles must be the same. Now what I can see next is that I've got a big triangle here, and the angles in that triangle must add up to 180. I can also see that I've got a straight angle here, so that must be 180 degrees. So I know that this bit of it is 58 degrees, so to get this bit of it, I'm going to take 58 off of 180 degrees. And that will give me 122 degrees. I know this angle up here is 32, so I'm going to add both of these together, get a total and take it from 180, and that will leave me with the answer. So 32 plus 122 is 154 degrees. And to get the shaded angle, it's 154 from 180, and that is 26 degrees. The next question, we've got a circle with some detail in it, and we're looking for the angle BDF. So the angle BDF is this one. So again, I'm not going to necessarily just concentrate on the final answer here, but just see what detail we can put in initially. Well, we've got this triangle inside the semicircle, and the longest line is the diameter. So I know that that is definitely a right angle, so I'm going to fill that in. Now if I then focus on this triangle here, I can work out the missing angle since I have 64 and 90. So 90 plus 64 is 154. I then take the 154 from 180, and that small angle in there is 26 degrees, which forms part of the angle BDF. I'm now going to concentrate on finding this smaller angle here. Now another thing that I can see is that I've got a radius and a tangent, which means this angle here must be 90 degrees. We can see that most of it is 77 degrees. So to get this small angle here, it would be 90 take away 77, and that is 13 degrees. Now, the next thing that I can see is this is an isosceles triangle. Since that's a radius and that's also a radius, meaning that those two lines are the same length and both of these angles are the same. So that small angle in there is also 13 degrees. So it's 13 degrees plus 26 degrees, and BDF then is equal to 39 degrees. Okay, so the next one, we've got the tangent MN touches the circle O with centre OL. Angle JLN, as you can see, is 47 degrees. Angle KPL is 31 degrees. Find the size of the angle JLK. Well, JLK, I'm just going to mark that angle. And that's that angle there, so JLK. Couple of things to note to get going. That'll be a right angle, and that will be a right angle. I also know that the radius and tangent will meet at a right angle here, so I can find this angle in here because that's going to be 47 off of 90 degrees, and that angle in there will be 43 degrees. So that's me get that part now, 43 degrees. I can now easily work out this part by angles in a triangle add up to 180. So 90 plus 31 is 121, and then it's 121 off of 180, which will give me 59 degrees. That part's 59 degrees, so it's 59 degrees plus the 43 degrees. Means that the size of that angle is 102 degrees. Okay, for this one, we've got the tangent SV touches the circle with centre O at T. Angle PTQ is 37 degrees, VTR is 68 degrees. Find the size of the angle PQR. So there's PQR there. Well, we can note that that's a right angle, and we can note that that's a right angle to get going. Now I've now got enough information to work out the size of that angle, since I know that angles in the triangle add up to 180, and that's 90 and that's 37. So 90 plus 37 is 127, and then it's 127 off of 180, and the angle there is 53 degrees. I've got the radius meeting the tangent here, so that must be 90 degrees, which means I can now find this small angle in here, which is 60 from 90, and that's 22 degrees. So I've got 22 degrees here, I've got the right angle, and I can work this one out. So again, 90 plus 22 will give me 112, and it's 112 from 180, and that will give me 68 degrees. So that bend there's 68 degrees. It's then just a case of adding both of these together. So 53 plus 68, and that is 121 degrees.